So we've got another reaction scheme. These have been getting progressively more complicated. So we need to remember about addition, elimination, substitution, oxidation, and now this one also includes acid-base reactions. So we've got 5 different types of reaction types we have to identify and write down into the reaction type boxes. We have to identify the products that are produced from each step, or the reactants they were produced from, and also the reagent when it is missing. So I want you to pause the video to see if you can write these reaction schemes down and the missing parts, and then check to see whether you got the same answer as me. Okay, let's start with problem 24. So problem 24, let's start at the bottom here. We can see we've got this amine here, and we're going to add HCl to it. So this is an amine, this is a weak base, we're adding a strong acid. This is going to be an acid-base reaction. Now remember, the hydrogen is going to get donated to the NH2. This will become an NH3+, an ion, and we'll just put the chlorine next to it. Oh, well, I didn't put the chlorine, but you could write chloride, sorry, Cl- next to it. And this is the organic product it's turned into. Now, this amine must have come from somewhere, and here we can see we added a reagent, which is alcoholic ammonia dissolved in alcohol, or we could say concentrated ammonia. That reagent is used when we want to substitute a halogen with an amine group. So the compound A would have been exactly the same organic molecule, but we've replaced the NH2 with a halogen. And in this case, I'm just going to use a chlorine. So this is the molecule that it could have been produced from. You could have put a bromine or a fluorine here. This is a substitution reaction. Now again, if I want to turn an OH into a chlorine, this is a substitution reaction, and I have quite a few choices here. I can use hydrochloric acid concentrated, I can use PCl5, PCl3, or SOCl2. In this case, I used SOCl2. Just note, if you'd chosen here this to be a fluorine or a bromine, you would have had to use hydrogen fluoride or hydrogen bromide here. Problem 25. Okay, problem 25. Well, let's go down. We've got a carboxylic acid here. It's reacting with a base. So, well, sorry, let's go to the top then. We have this haloalkane. I want to turn it into something that's going to become a carboxylic acid. So actually, I'm going to turn it into a primary alcohol. So this is going to be a substitution reaction. I've added potassium hydroxide in aqueous. Okay, it's in aqueous conditions. That means that it will produce the alcohol, and it will swap out the OH for the Cl. And the reason I chose that is because I knew this had to be a primary alcohol, because that's the only way that I can make this carboxylic acid group. And we see here that we're adding an oxidizing agent to the primary alcohol, so this is an oxidation reaction. Carboxylic acid here, if we add it to a strong base, of course, we're going to lose the hydrogen, the H+, and we're going to make this a butanoate. But this is an acid-base reaction, and we're going to make this butanoate ion. And remember, we can put the Na+ beside this as well. So the next step, the next scheme, sorry, 26. We're going to start with this compound at the top here. This is propene. We are going to add what? Okay, we've got HCl as our reagent. Obviously, this is going to be an addition reaction. There are 2 products. The major product will be the one where after the double bond is broken, the hydrogen attaches to the carbon with the most hydrogens, and the chlorine will of course attach to the other carbon, the second carbon. So this is the major product, and the minor product will be when the hydrogen attaches to the carbon with the least hydrogens, and the chlorine attaches to the first carbon, and this is the minor product. So now we have this. We see here that the product after the next is the carboxylic acid. So that must have been made from a primary alcohol. So this needs to turn into a primary alcohol, and to do that we have to have a substitution reaction, and to do that we are going to use sodium hydroxide, and it's going to be in an aqueous solution, right? So remember that if we have sodium hydroxide aqueous solution, it makes an alcohol. If we have an alcoholic solution, it makes an alkene. So because this is an alcohol, we turn it into carboxylic acid. We know this is an oxidation reaction. We are going to either add acidified permanganate or acidified dichromate. In this case, I chose acidified permanganate, MnO4- /H+. This carboxylic acid is going to react with sodium carbonate. It will produce carbon dioxide bubbles, we observed. This is an acid-base reaction, and it's going to produce a carboxylate ion, a propanoate ion, plus the sodium that goes with it. And this is the answers to these reaction schemes.
Hey, thanks for watching this video. Hopefully this has made you more confident with your chemistry. Don't forget to like, subscribe, or leave a comment about anything that you want to with this video or any questions you have. I'll see you later.